Hey guys, Mr. Bouchard here, and today I'm here to talk to you about topographic maps. All right, so I'm going to start out with some pictures first. All right, and obviously the picture you're looking at, very deep hole in the earth that you can see from space. This is the Grand Canyon. So what does this look like from an aerial view? Ready? So here it is from satellite photograph. This is Google Earth or Google Maps. All right, and you can see here the terrain. You can see the river running through it, which is the Colorado River. All right, on this map, it's not so clear the elevation changes. All right, you can see a little shading. All right, but once I add the contour lines, all right, and I'm zoomed in a little bit, you can see the changes in elevation. So the lines will kind of give you an idea how fast the elevations are changing. Okay, so the closer the lines are together, the steeper the slopes, like in this area. And then the areas where they're further apart, that means that it's a gentle slope. Here's another picture of that same thing, all right, zoomed out a little bit. And again, steeper slopes where the lines are closer together, and then gentle slope when they're further apart out here. Here's a map of, or a picture of Mount St. Helens. Okay, this is actually a volcano that erupted in 1980. It's in Washington State, not too far from Seattle. All right, and you can see basically the eruption. This side of the mountain got blown off. And you can see here, you can't really see that elevation change other than the tree line. All right, so above the tree line, you don't have any, you just have rock structures instead of trees. All right, that's the only reason you know it's high elevation. I go a step further, you put the contour lines on, look, you can see the changes in elevation. Okay, so it's one of the uses of a contour map, which we'll talk more about. Here's Washington, Mount Washington. This is actually in New Hampshire. Very nice vacation spot if you ever want to go up there. You can't really see, again, changes in elevation in this picture, but this is the highest peak on the East Coast. So if I put the contour lines on, you'll see it's higher than 6,200 feet. So very high peak. And you can see the changes in elevation once again. Steep slopes, again, lines close together. So what is a topographic map? Topographic map or a contour map is a model of the elevation field of the surface of the earth. Elevation is height above sea level. So that's what we measure off of, and I'll show you where sea level is measured upon. Contour lines are lines that connect points at equal elevation, and they will always go up by what's called a contour interval. That's a difference in elevation between two consecutive contour lines. So let's take a look at this and understand this a little further. So what do we use topographic maps for? Definitely for planning for building homes. My brother happens to be an architect out in the Hamptons, and obviously these ginormous houses they build out there, they really have to plan the property out in terms of drainage. They don't want water coming into the basements of these homes. So definitely topographic map could be used for that situation. Mining, definitely. We've got to figure out the terrain of the area. Orienteering and hiking, so that's a hobby that some people have, going up the sides of mountains. And then of course, if you're a geologist, interpreting the past, right, which we'll talk about in future chapters. All right, so here's an example where sea level is being talked about. So what happens at sea level, it does change because of tides. But whenever we look at sea level, we base it on the mean sea level, which basically is the average sea level. So when we look at sea level, that's what it's based on, and that's 0 feet or 0 meters. And then we count up from there, and that's our contour map lines. If we go below sea level, then it becomes depth. Right, we measure the depth of the ocean or negative elevation. Right, that's the other way you could talk about it. So in certain situations, we talk about it in different ways. How do we create contour maps? Number one, we survey the land. So this is surveying. You might have seen this happening when they were building roadways in our area. They look through this scope, and then another person down the street is holding some sort of measuring tool, which they line up to, and they can make see how much the elevation has gone up or down using that. For satellites, definitely more recently are being used. It's called remote sensing when we do that, and that's becoming more common because it's basically much faster and more accurate, obviously. But again, people have to have the know-how to use the satellite data and create the maps. Okay, so how are topographic maps created? So I'm going to start out with a sea island example. All right, so this sea island example, obviously, I'm going to go over the smartboard. The first line, obviously, is going to be sea level. All right, on a sea island. So the outer part of the island, because this is the ocean, automatically is 0 feet. All right, 0 meters. All right, as we go up from there, then we measure by a certain interval. So I'm going to show you in the next sequence. They chose 20 feet to go up by. So what they'll do is go around the island, find out where it's 20 feet everywhere, and then mark those points and then connect them up in an isoline. So that's what they do to create the map. They do that all the way up to the top of the mountain. So they went by 20, so 20, 40, 60, 80, 100, okay, up to the top of the mountain. Point P from the previous slide, you'll notice they said it was 115 feet. Occasionally they may ask you what's the minimum and maximum value that P could be. All right, so what you do on that, you take the last contour line before P, you add 1 to that. That's the minimum value it could be, is 101 feet up to 1 less than the next contour that is in existence in that map. So 120 would be the next one, subtract 1, 119. So P could be anywhere between 101 feet and 119 feet. So if they ask you the range, that's what you would put down. If they ask you to estimate, you just pick a number in the middle of the range somewhere. I actually recommend you pick a number in the middle rather than to write the range. Because if you write one number wrong in the range, you're going to get the answer wrong. So if you wrote 101 to 120 feet, you'd be incorrect. So just be careful. So what happens in the center of a volcano? So this is the same idea, but a volcano island. You guys know elevation will decrease. There is a crater in the middle of a volcano. So how do we do this with contour lines? So contour lines, obviously going uphill, are circular lines, loops. To indicate a going down in elevation or depression contour, we use depression contours. So depression contour lines indicate a decrease in elevation, and the rule is the first depression contour has the same value as the last regular contour line, all right, that it's inside of. So it will be 40 and then 40 again, because anywhere in between this, it could be like 43 feet here, all right, or 42. So, and then it will go back down to 40, and then the next one down will count down by the contour interval. So just to reiterate that fact, so if you have 60, 50, 40, right, it will continue downward after that. So this is going by a 10-foot interval, this map. Same with this one over here. Now this one's in between two contour lines. So the rule is, you'll look at the two contour lines that it's between. The depression contour will follow the smaller one that is between first. So you notice 60 and 70, so it's going to take on the value of 60 and then count down from there. So make sure you understand that rule. So a depression's in the middle of two contour lines, that's what you do. All right, you take the value of the lower one as the first depression contour and then count down from there. The reason why, because in between here, again, this could be like 63, and then you hit 60 when you go back down. So that's the way that works. All right, streams. Streams make a special V shape. The reason why is step into a stream, you go down in elevation. So the contour lines will tend to bend upstream. Okay, so you can see if we have a stream here, like in this example, that would be upstream because again, the contour lines bend upstream. They make a V shape that the bottom part of the V shape points upstream. That's the way you can write it. So make sure you get that wording down, guys. So how do we know which way the stream flows? The bottom of the V shape made by the contour lines points upstream. Or you could say the contour lines point upstream, right? Either way, just make sure you get some sort of way to explain that, okay? Here it is on a contour map, all right? So again, the V shapes, you follow them, and sometimes they'll tell you which way is north. So if north is upward on this map, this river upstream is this way. So therefore, the river is going to flow this way. Flows opposite the way the bottom part of the V shape points. So this river is flowing south. Okay, so you have to say that in words with the which compass direction it's going. All right, same thing with this map. So again, north is this way. So if you look at the V shape, you got to get a compass direction. So never eat soggy waffles, okay? And you notice the V is pointing this way, so the river is going to flow this way. So the answer is northeast. So river flowing northeast. So make sure you understand that. If they say general compass direction, you could put north, south, east, or west. You don't have to actually do northeast, southeast, northwest. So whatever you're more comfortable doing, you can do that with the rivers. Okay, the last rule I want to talk about is index contours. Index contours are the darker contour lines on a map. Usually on a map like ones we saw initially with Mount St. Helens and all that, those maps have a lot of lines on them. So the convention is the darker lines are labeled, the lighter lines are not. So every fifth contour line, there are the ones that are labeled, and you can figure out the contour interval from a simple rule. Take your two index contours, which in this case happens to be 800 and 700, okay? And what you're going to do with them, you're going to subtract the index contours and divide by 5. So I take 800 minus 700 and divide by 5. Okay, so if I do that math, 100 divided by 5, my contour interval in this case is 20 feet. All right, because these are in feet. So that's a quick little way to figure out the contour interval, and then I can go back and double check. So 720, 740, 760, 780, 800. So I am correct the way I did my contour interval. So always double check, make sure you calculate it correctly, and this will help you to interpret a map better. So once you do figure out the contour interval, then you can actually label each line, and then you can figure out your answers easier. All right, so that's a little technique that definitely I encourage. So I thank you guys for tuning in here today. So again, just practice up some of these rules. Make sure you know the rules for the river and index contours and all depression contours especially. Those are things that people tend to make errors on. All right, thanks for tuning in. I'll see you next time.